Okay, last thing we're doing is verifying inverses. A function and its inverse have a kind of unique property that if f and its inverse are truly inverses of each other, then the composition of f with its inverse of x will equal x, or the composition of f's inverse with f itself will equal x. In other words, if I put, in this case here, if I put the inverse into the function itself, it should equal x. Or if I put the function into its inverse, it should equal x. Okay, now, left some room here because I just want to make some sense of this quickly. Again, back to this diagram that I think really helps, especially later when we get to trig inverses. Okay, look, well, basically what this is saying is, I'll take this one in red over here to explain it. I'm going to put x into f. It's going to give me some y out. Okay, that y then we put in to f of x, which gives me back my original x. That's really what's being said here. The other one over here starts on the other x. But basically that's what's being said. If you think of this diagram, kind of makes a full trip around. So here's the basic idea here. Verify that the inverse we found for the function that we used on the front page is its inverse. Okay, well, first off, we found that the inverse in this case, its inverse, I'll go up here, find it again, was the cube root, right? Was the cube root of x plus 1 minus 2. Okay? So, according to this property, we should be able to take, in this case, let's go ahead and take the composition of f with its inverse. Okay? In other words, we're going to take f and put the inverse into it. And that should equal x. So if I do that here, if I have my blue is my original function, okay, then here's what I have. I have this whole thing, the cube root of x plus 1 minus 2 plus 2 cubed minus 1. The blue part is the original function. So I just plug the inverse in for the x, okay, and now we start simplifying. First off, you'll notice negative 2 and positive 2, if I add those together, they'll cancel out. So I'll be left with this. I'm just going to switch to blue altogether here. I get the cube root of x plus 1 cubed minus 1. Now you'll notice that the cube root and the cube cancel out, okay, which leaves me with x plus 1 minus 1, which equals, right, x. And if you look there, that's what we're supposed to get. So in this case, we're verifying that what we found was truly the inverse. Now you could do it the other way, where you plug f into its inverse. Either way, it should come up with x.